So chapter 5 is all about probability. Probability is a chance behavior that is unpredictable in the short run, but has a regular and predictable pattern in the long run. So the law of large numbers says that if we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs approaches a single value. That single value is called a probability. A probability it will always be between 0 and 1, and it describes the proportion of times the outcome would occur in a very long series of repetitions. So look at this chart here. As you can see, this is just recording the number of heads that we had in a series of tosses. So between 1 and 22 tosses, the proportion of heads is very irregular. It starts off right at 1/2, but then it dips down below 1/2. It reaches 1/2 again and goes up above it, and it's going to go back and forth from there. 22 would not be that many tosses. However, if we tossed the coin 500 times, as you can see, the more we toss it, the closer the proportion gets to 1/2. So that's what the law of large numbers says. It will approach a single value, and that single value will be the probability. So the probability that when I flip a coin it's going to land on heads is 1/2. So turn to page 286 and do the check your understanding. So number 1, well, I'm not going to read these to you. You guys can pause it and read it and just let me know the next class if you have any questions on these. One thing I would like to say about part B, you do need to know how to interpret a probability, and this would be a great sentence to kind of memorize. So whatever your sample is, however many in a random sample of 100 adults, we would expect that around 61 of them will usually eat breakfast. So it will not be exactly 61, even though that is the probability is 0.61. It's going to be about that number. So if you were to toss a coin 6 times and record heads and tails on each toss, which of the following outcomes is more probable? Heads, tails, heads, tails, tails, heads, or 3 tails and then 3 heads? So if you said they're equally likely, then you're correct. Half are heads and half are tails. The probability does not predict order, so the coin has no memory. So it doesn't matter what you tossed the time before, it does not predict what you will toss the next time. So let's say that you were going to have flip a coin 6 times and you got 6 tails in a row. Would the probability of getting a heads the next time, the 7th time, be more likely than the probability of getting a tails? This is called the law of averages. So you're saying that tails has happened so many times that the next one has got to be more likely to be heads than tails because we've had so many tails. And this is actually a myth in probability. Heads is still equally likely as tails for the 7th toss. The coin has no memory. It doesn't know what the previous tosses have been. So heads will still be 1/2, tails will still be 1/2. So here's some definitions you need to learn. The sample space is a set of all possible outcomes in a chance process. And the probability model is the description of some chance process that consists of 2 parts, the sample space and the probability for each outcome. So for tossing a coin, your sample space would be heads and tails. To make it a probability model, we would then need to indicate the probability of each. Well, the probability of heads is 1/2 and tails is 1/2, so we could just indicate that. So here's another example. Give a probability model for the chance process of rolling two fair six-sided dice, one that's red and one that's green. So here's all the combinations of the two die. So the sample space, there's 36 possible combinations. So the probability of getting each one would be 1 out of 36. So probability models allow us to find the probability of any collection of events, a collection of outcomes. An event is that collection of outcomes from some chance process, and we usually indicate it by a capital letter, A, B, C, and you have to label what the letter represents if you're going to use a letter. So if A is any event, we write it as P parentheses A, and you kind of saw this a little bit in the chapter 2 unit. We use that symbol quite a bit. So if we define the event A as the sum is 5, it would be these 4 combinations. So the probability of A would be 4 out of 36. And typically we do reduce them. If you don't reduce it, it's okay. So if you left it as 4 out of 36 or you wrote it as 1 out of 9, either one would be counted correct. So let's say that B is the event that the sum is not 5. So instead of having to count up all the ones that aren't 5, we could just subtract that from 1. So 1 minus 4 out of 36 would be 32 out of 36. And again, you could simplify this if you wanted to, but it's not a requirement. So if you simplified it, it would be 8 out of 9. So here's the basic probability rules. I'm not going to read through each one, but a couple things I do want to point out. A probability does have to be between 0 and 1, and if you have all the possible outcomes, they need to add up to 1. You can find the probability of any event by doing the number of outcomes corresponding to the event divided by the total number of outcomes in that sample space. In that example we just did where we did not A, or the ones that were not a sum of 5, this is called the complement. So when we found the probability of B, we were finding the complement of A, and it's denoted with a C in the exponent. And so then another vocabulary word you need to know down here is mutually exclusive. If two events have no outcomes in common, they cannot happen at the same time. They're called mutually exclusive or disjoint. They can never occur together. Then if you're doing the probability of A or B, you can just add each probability together. So look at this example. Show that this is a legitimate probability model. For it to be legitimate, each of the probabilities have to add up to 1. They're each between 0 and 1, and they have to add up to 1. If you were to add all of those together, they would equal 1. Part B says, find the probability that the chosen student is not in the traditional college age group 18 to 23. So we could do this 2 ways. We could add together these 3, or we can just do 1 minus 0.57. Either way, we're going to get 0.43, and that's our probability. So go to page 303 and do the check your understanding. Take a look at these and jot down any questions that you might have for me in class. So here's another example using a two-way table and probabilities. This one gives the total count. Sometimes you may have a two-way table that has probabilities in it, and sometimes it's the counts. So event A is male and B is pierced ears. So the first one, we're finding the probability that someone has pierced ears. So this is the probability of B. So we go to our chart and we look at the total pierced ears. That's 103. And we're going to do it out of the total. So 103, if I can write, out of 178. Which equals 0.58. And you can leave them as a fraction or a decimal. It really doesn't matter. It's up to you. So then the probability that it's a male with pierced ears, would be 19. So you would do 19 out of 178. Type that in your calculator. We get 0.11. And the last one is a male or has pierced ears. So the male category would be 19 and 71. And then pierced ears would be 19 and 84. We don't want to double count any of them. So I'm going to add the numbers in the middle instead of adding the totals. So I get 174. So 174 out of 178. Now the other way I could have done this, I could have looked at that who didn't fall in that category, and that would have been the females with no pierced ears. So I could have done 178 minus 4, and I still would have got the same top number. So 174 divided by 178 is 0.98. So there's those three probabilities. So here's the general addition rule for two events. If A and B are any two events resulting from some chance process, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Now, if you noticed before when I said the probability of A or B, you may have seen me leave this part off. Well, if the two events are disjoint, meaning they never happen at the same time, that would be the rule. But in this example, you see that there's an overlap in the Venn diagram. These two could happen at the same time. Therefore, if I were to add them together, I would be adding the part where they overlap twice. So since I would be adding them twice, then I would need to subtract the section that I added twice. So if I go back to this example, this would be if I use my totals. So if I was doing the probability of male or pierced ears, I would do 90 over 178. That's the probability of being male. And then 103 over 178. That's the probability of having pierced ears. Well, which number falls in both of those categories? It's 19. So I would need to subtract 19 out of 178 to make sure that they didn't overlap. Now notice that I did that problem without having to worry about that formula. So that formula is important to know, but it is possible to do this problem without it. So look back at this example. 90 over 178, that was males. 103 over 178, that was pierced ears. And then 19 over 178, that was both. So to do this, I would do 90 over 178 plus 103 over 178 minus 19 over 178. And I get the same answer that we did on the page before. One clue that you maybe need to look at this formula and subtract the ands is if you get a total that is bigger, that's going to give you a probability more than 1, because we know that probabilities greater than 1 do not exist. So had I not subtracted the 19 over 178, then I would have had 193, and that's not possible. So go ahead and try to check your understanding on page 305. Here's your answers. Take a look, jot down any questions that you might have. All right, the last thing I'm going to talk about is how to do Venn diagrams. So a lot of times we represent the probabilities that we're finding with Venn diagrams. In each of these, the green portion is the probability that we would be looking for. So A with an exponent of C, that means the complement. So that is the probability of the outcomes that are not in A. So that would be outside the circle. If two events are mutually exclusive, we've already talked about this, they have no events in common. So the two circles should not overlap. The intersection of A and B, that's A and B, would be the part that's in both A and in B, and it's represented by the upside down union. When you have the union of A and B, that's A or B. So anything in A or anything in B. And that also includes where they overlap. So make sure you know these symbols and where it's represented in a Venn diagram. So take a look at this example. This is about the males and females with pierced ears. And I'm going to draw the Venn diagram of what this would look like. So we would have males in this circle, pierced ears in this circle. So we'll label this A and this one B. And then a lot of times we put a box around our circles to represent what's not in our circles. So there are 19 males with pierced ears. So that would be your overlap. There's 19 in there. There are 71 males with no pierced ears. So that would be in this one. There are 84 females with pierced ears. That would be in this category. And then no pierced ears and a female would be outside. So if I added all four of these numbers, it should add up to our total of 178. So down here, let's just practice doing the symbols. Male and pierced ears, that would be A and B. Now if I was looking for the probability of those, I would put a P in front of it with parentheses around it. Male and no pierced ears, that would be A and not B. Female and pierced ears would be not A and B. Female and no pierced ears, that would be not A and not B. So this would be 4. Female and pierced ears would be 84. So that's inside circle B, outside circle A. Inside circle A, outside circle B. That's male and no pierced ears, that's 71. And male and pierced ears is 19. So that's just practice with what the symbols look like and how to fill out a Venn diagram. And that's it. Thanks.